Okay, so here we are.
Full start. Offense.
Here we are on a wonderful Saturday at the Bumpin' O'Malley factory. And what are we doing in this video? Oh, so we're gonna try to not be consistent and to just drop a bunch of videos randomly all at once because it's fun to f with people. There's only 2 bells. We got Haley painted. Say hi, Haley.
Hi.
Everyone loves being here. So we're talking about 3D printing. That's right. So 3D printing, I used to be like bearish about what it's useful for, and then I got a good 3D printer. So I've always 3D printed bending forms, and like this one right here. This is a new one we're working on. So 3D printing bending forms, they work well for prototyping. It's for prototyping. A lot of people like try to use them for production and then it doesn't go very well because it's a piece of plastic. But stuff bends better against steel. But when we're figuring out the shape, because you know, this is not a crook we made, as you can tell by, we're just kind of referencing Spam with this shape. You hand bend crooks, there's all types of spring back wackiness. So like, this is the spring back side, so we'll bend the tube around this side, and then it comes in here, and then it'll go whoop, end up at the span we want it to be. But we actually put spring back compensation on this side as well, so the form is not like straight and then sprung back, it's like pigeon-toed on both sides. This side more than this side, but there is a pigeon toe on this side, and that's what we found to get the best results. But we got this 3D printer last summer. Before this I had a Creality CR10. This is about 60% infill. So this on my CR10 would have taken like 16 hours to print. And we did print a lot of bending forms on it. On this machine, this takes like 2.5 hours. And it's much improved. The quality is so much better. It's very flat. I've had to do like no maintenance on this thing and it just kind of worked out of the box. And it has like the super sweet auto magic material changer thing, which is cool. I don't use it super often, but it's nice because I can put 2 spools of white in here, and then when this one ran out, and then it automatically switches to this one during the print, so you never like lose the print because you ran out of juice. Yeah, I would highly recommend. It's a little bit small build volume, but for what we do, it's perfect. This is just about the biggest form we'll print, but we do everything with it. We don't just do bending forms; we do cooler stuff too. Move. So, we have cutting fixtures. Cutting fixtures, that's our hand slide crook cut fixture. We have dapping blocks. We dap that shit. That's our hand slide crook bow guard. You can see the impression it's left in there. So we dap that. This one's pretty cool. So this goes in the vise. So you can, when you're doing, this is specifically made for hand slide tubes when you're making sub-assemblies, so you can just lightly clamp this and then do some ragging or whatever you got to do on the tubes. You know, it's just got some felt in there, and we just really gingerly clamp it. Nice. We do stuff like this too. Like this is a little bushing for our lathe here, so when you're putting a tube in here, it doesn't go. But these are awesome because, you know, a lot of people will just put a fence on a bandsaw or a table saw and then like put the crook against the fence, and then it's like gonna get cut like the Leaning Tower of Pisa, and then it's gonna be like a trumpet. Slot here, a rail here that goes in our slot on the bandsaw, and then you go, and you have a pretty consistent cut. It'll be more consistent on the table saw next time. Another fun one. This one's pretty fun. This is the same fixture with the rail for our main tuning slide crook, which are hand bent, so they're slightly inconsistent in terms of the shape, and we kind of have it. It works really well with this. It's constrained minimally because the crooks are going to be slightly different. They all fit in this very consistently and get cut the same way. Pretty cool. There's a couple things I don't believe in 3D printing for, and that's ball-out dies. People try to 3D print ball-out dies, and you get a result, but you don't get a good result. The cooler thing, I did a cooler thing over here. Oh, look at 8R. Look at 8R spinning a thing. Can we video you spinning a thing?
Yeah, if you think I can do it.
This is his first bell ever, guys.
That one didn't count.
That one doesn't count. Pretty cool.
And now back to your regularly scheduled program.
This is my magnum opus though, as far as 3D printing. So one of the biggest limiting factors to scaling, like making a trumpet or even just selling trumpet lead pipes, is cutting Venturis consistently. And in an effort to figure that out sooner rather than later, I 3D printed this fixture. So this fixture, this is 3D printed, this piece here, and it again rides in the rail here, has a couple of supports. Then I have this threaded rod, and this threaded rod is the is the diameter of the Venturi we want. So this one in particular, I think this is a 347 plug. Here's a lead pipe blank I got a scrap in. So what we do is we will set, this one's already set, but I have these two little lock nuts back here. We will set it, see how it's far away from the blade now? We'll set the screw so that the plug there is just shy of the blade. Then you tighten it down, check it, make sure it's good. Then you slip your lead pipe blank off the drawbench right on until it stops. And then the only important thing here is this can move. You can hold this up against the 3D print there. Boom. Pull it off. Don't cut your hand off. Okay, don't do this at home.
Yeah, deburring with calipers. Yeah, baby.
Oh yeah, baby. Oh yeah. But that's pretty cool. This is one of my favorite things. We're gonna make a bunch, because these plugs will just thread right off. You can put a 345 on there. You can put a 382 on there. You can put a 370 on there. You know, get a little 390 going on, some 450 going on, 450 Venturi. Without 3D printing, this is kind of a bitch to make. But with 3D printing, this took like 5 minutes to design in Fusion, and then it just exists. And then when I break this, it can exist again. Everything's recorded, there's no tribal knowledge anymore, it's just can we find the computer file, which...
We had another manufacturer that visited, and he was looking at all the 3D printed stuff we had around the shop and laughing because he was doing the same thing. Cutting fixtures, things like that. It's just super useful. You don't have to either make them yourself or pay someone else to make them for you.
The lead pipe is cool, but I forgot about the other coolest thing. So when you inside spin, we have these spinning cups. So these are plastic. A lot of factories will do steel or aluminum ones. This is not a form for us, it's a guide. So you put the bell in, I'm not gonna set it up, but the bell goes in there and they spin from the inside. You see us do it. Maybe not on this machine, but on the older machine. But the thing that is tricky is somehow the bell has to be secured in the lathe, because if it's just free balling it in there, it's just going to spin freely with, you know, when you try to put pressure on it. When we switch to this machine, the bell blank is shorter than the lathe. So the bell blank ends about here. So what I did is I made this little spindle liner, and if you look in there, there's a 3D printed, two 3D printed parts that are, well, okay. Let's see how I got there. I mean, you know. So this goes in the spindle, and then a bell. Okay. These are our inside spin sample. For each round, the bell gets pushed into the machine just like this, and then it holds onto there. And it's just enough pressure to keep the bell from spinning when you put pressure in here pulling it out. And that's one of my favorite things. And this is printed from TPU, which is a flexible 3D printing material. Because if we printed it from PLA, which is what I print almost everything else from, they would just crack right off. This is the flexible I was talking about. You can think pretty sweet. So that these little grippers don't immediately just shear off. Because you got to imagine we're kind of just jamming, like I just broke one, just kind of jamming in there over and over and over. But they last a decent amount. I think there's some improvements we can make. But even then, you know, we've spun probably close to 100 bells since we started doing this, and this is we've maybe gone through 10 of these liners. It's actually not that bad. Pretty much one per batch, which is reasonable. This foam was really cheap, and I think it's recyclable. That's cool. But yeah, that's my favorite thing. That's the most smartest thing I've done in a long time. we also do this. These are for making French bead wire. So we'll put this in the lathe and hook our half oval wire around here, and then we'll turn the lathe on really slow and just kind of guide it into this channel. This is like C trumpet. This is like bigger diameter, like 5 1/4 trumpet, and this is the large bore tenor. I gotta remake this one because this is my old 3D printer quality. What do you think of that? It probably took 22 hours to print or something too.